In this video, we're going to start talking about cubic expressions. Here's an example up here, a very general example. And then in the next video, we'll begin to solve some of them, at least simpler forms of them. We won't have all the tools to solve any cubic expression until later in the series. It's a lot more complicated, but just with simple algebraic methods, we can solve a lot of them. We'll also be looking at the shape a lot of them make in this video, and I'll be talking about the roots or the solution to an equation and their factors, what they are, and they're just like quadratic expressions. So if you were unsure on that, we'll talk about it again. So let me jump right in and just draw a few examples of things you might see. This should be a shorter video. First, I'll do one where a is bigger than 0. So remember what a is just a number in front of x squared. Oh, sorry, x cubed. Also, I should say this is what a cubic expression looks like. It's the most important thing here is the 3, x to the power of 3. Once a is not equal to 0, this is a cubic expression, a polynomial of order 3. All the other numbers, the b, c, and d, can be anything, including 0. And yeah, I'll just draw out the general shape of it. Now, it's actually quite a powerful tool. Something that you should probably know is how to begin to draw graphs. Now, we'll do a lot more when we get to calculus, because we'll have more tools on how to draw, especially cubic expressions. But for now, I'd like to draw your attention to one thing you can already do. I mentioned it in the quadratic video, but if a is 0, I already know, not a point, but a general area that this expression will go to. Because x is to the power of 3, that means it's going to dominate these other expressions, these other parts. It's so much bigger than x squared. Think of it if it was a million or a billion or a trillion, or even bigger again. X cubed would be the only number that mattered. And of course the number in front of it comes along for the ride, as it were. Now you'd see this a lot in sciences, engineering, computer science. They would often just straight up ignore lower orders. They might only take 1 or 2 orders, because that would be close enough. If you were dealing with traveling millions of miles in some sort of space ship you were making, and you had an expression like this, where the function was whatever, I don't know what it'd be, and you could safely ignore some of these terms. Your answer would still be correct to 7 or 8 degrees off it. So that happens a lot. And so in maths, we're just saying this would dominate. So it'll just give me a general idea where it comes from. So for example, if x is a positive number, let's say a big positive number, let's say plus a million. Here's x, here's the x line, and here's the fx line. If x is really big, as far out here, the number that comes out of this will be really big. Because I don't have to care about these guys. All I know is x is big, so x to the power of x to the power of x is a positive and really big. So once a is bigger than 0, it's going to be up here somewhere. It's going to be somewhere up there. And it sounds childish and easy, but learning where the function is at extreme points can be useful. And again, when x is a small number, like, and I'm not saying small like a half or something, I'm saying small like minus a million, minus a billion. We'll get minus by minus by minus is a minus, and it's a really small number then, because a million times a million times a million. A is positive, positive times a minus, we get minus down here somewhere. So the function is going to look something like this. I'll just draw one of the more common shapes you will see. That's a cubic that has 3 roots. Remember what the roots are? The roots are if this expression equals 0. The solution if it was an equation equaling 0. They are the roots of this cubic. I'll talk more about them towards the end of the video. And they're really powerful roots there, because we can get factors from them. Yeah, I'll use this one as an example later in the video. Let's say 5 minus 1 and minus 4. I'll be able to get that equation just from those numbers. Now let me just do an example of if a was less than 0. we just get the opposite. Instead of a plus by a plus by a plus by another plus, this becomes the x's are all plus. 3 pluses make a plus, but the a is a minus, so we get down here somewhere. Again, 3 minuses make a minus, but then the a is another minus, so we get some number up here somewhere. And we just get something like this. Again, this is just a common looking cubic. They don't all look like this. I'll draw a few examples of what we might see. We might see ones that look like this. This only has one root. That would be very difficult for me to get any information from. I would have to look at a line up here, say, instead of putting fx equal to 0, this line, I'd have to look at what happens when fx equals, I don't know, 5, let's say. And I could get an expression now for that. We'll look at this perhaps at some stage. I'm not sure if we will get around to actually. Broad strokes this series is planning to be until I get specific questions that I can delve deeper. Yeah, it can look like this, can only hit the line once perhaps. Another common one would be something like this. Looks like a completely different shape to these guys. But if you were to play around with these numbers, go to a web page, search for a cubic, graphing cubic equations, something like that. There'll be plenty of web pages that will let you put in whatever number you want. Play around with it, you'll get one that looks like this. An easy way would be to put in some zeros. We'll get expressions that look like this. It just means this has actually tightened up a lot. These two humps have come in closer and closer, and closer and closer to the middle and closer to each other until they're on top of each other and we get a flat line. But this is a common enough one. If I knew the shape was like this and I knew this is the root, I could actually get the expression of this. Let's say that's 3. I'll do this one out as well quickly. That's it. That's generally it. Like we've other shapes we could get. We could get this one. That would just be with a different d. Different d to get it to rise up. So we have lots of shapes like that. But for this point in the course, we won't have to do anything too complicated. Because we'll be dealing with simpler expressions, because we haven't yet learned calculus. We haven't yet learned iterative methods that can solve cubics in different ways. So we're going to be left with simpler ones. So I'll leave you guys with just, I'll show you how I could maybe get this expression. Because I'd like to remind you about roots. This equation here, in fact, I'll rub out the rest of these. So this guy here, if I was given this this equation, if somebody showed me this picture, I could actually get out the expression of it, just like we could in quadratics. It's simply by noting that the roots are given to me. The roots are equal to -4, -1 and 5. And if I know they're the roots, then the factors are simply, I won't put in equals a bit confusing. Roots are, the factors are x plus 4, x plus 1 and x minus 5. They are the factors of this expression, meaning that any one of these would divide into this expression evenly. So think of it like we learned factors for numbers when we were children. 8 has factors 1, 2, 4 and 8, any of which would divide into it. So think of 2 dividing into 8. It would leave a 4, which is another one of the factors. Again, this will divide in and leave the other factors. If I divided this into the final expression, I'd be left with these two. But I can do a little more. I can actually multiply these together and get out this expression. Let's see. Oh, actually, maybe I can't. Yeah, you know what? I can do it quick enough. Let me move these commas so it's just a mathematical expression. Yeah, I won't teach it too well. I'll just do it out fast. We have x times x times x. We get x cubed. Then I wouldn't necessarily recommend doing this. I'd do it slower than this if you're doing it yourself. But I have a lot of practice, so I will just look and say, well, there's a lot of anywhere an x squared will come from. An x squared will come from an x times a number. So we'll get x by x minus 5, we'll get another x by x plus 4, so that's we're at minus 1, and plus another 1. We'll actually get 0. 0 x squares out. Then all the x's, we'll get an x times this number times this number. So we'll get minus 5, we'll get plus 4, which is minus 1, and we will get minus 20. So that's minus 21, I believe. Minus 21x. And then the numbers, 4 times 5 times 1, we get minus 20. And that's what this expression would look like. I can, of course, just rub this bit out. That was just me showing you that there's 0x squared, but doesn't matter. That's what this expression would look like. Although I haven't drawn it, so if you put this in on a computer, probably wouldn't look like that. One other quick example, because I had it here on the screen. One that looks like this. Let's say that's a tree. I can get this, even though it only has one root. So this, I would say maybe the root is 3 factor is x minus 3. Well, that's not enough to get a cubic. I need 3 factors of it. But the thing is, I can notice from this is there is 3 factors. They're just all at the same point. There's no point on this expression that would give me the 3. This is just something you learn, by the way. It's really the roots are actually 3, 3, and 3. We don't always write that, and the factors are x minus 3, x minus 3. So really the expression is just x minus 3 cubed, which you can do out if you want. It's x cubed minus 6x squared. Let's think it's 9 plus 18 plus 18x, and it's minus 27. Alright, I've lots of practice doing things like that, so don't worry, you didn't have to be able to do that in your head. Yeah, that's it. Next video we'll actually talk about solving these, what you would really expect to see in an exam and stuff. But this is the sort of shapes we'll be dealing with. Thanks for watching, and I'll see you next time.